All right, guys, we're going to move on today to margin of error. So what we're going to do with it is we're going to estimate the population means and proportions, and we also use it to develop the margin of error from simulations involving random sampling. So this is one of those big ones that you do see in day-to-day life. You see it in real-world situations, especially when it comes to elections. So like all of our examples today are going to be tied to elections. When you see some kind of voting going on, whether it's, district officials or county officials or, the United States, the big one every 4 years, when you see the results come in on your TV, if you ever watch that with your parents, you'll see at the bottom of the screen, it has the results, but then it'll also say plus, minus, and then a number, okay? That is margin of error. So we're going to see what that really is and what does that mean, all right? So a probability sample is a sample selected by using a random process. Okay, we already know this. We've been doing this this whole time. That's the best way possible. The new stuff, so a margin of error of a random sample defines an interval, okay, centered on the sample percent in which the population percent is most likely to lie, okay? The interval for margin of error, that's the percentage that you see the plus minus next to on your computer screens, okay? So let's see an example. All right, example 1. Students at a high school will vote on a proposal to start classes later in the day. According to a survey of a random sample of students, 54% of the students agree with the proposal and 46% of the students disagree with the proposal. The survey's margin of error is positive and negative 5%. So we're going to use the margin of error to find an interval in which the actual percent of the students who agree with the proposal is likely to lie. Okay, so for those who agree, we're going to subtract and we're going to add that margin of error. Okay, so let's see here. 54% agree, and my margin of error is positive and negative 5%. So we're going to do 54 minus the 5, and we're going to do 54 plus the 5 to get our interval. So the actual percentage of students who agree is going to be anywhere in between 49 and 59%. Okay? So it's not exact, it's going to be somewhere in between there with our margin of error. All right, let's do another one. Here, a city is about to hold an election, and according to the survey of a random sample of city voters, 42% of the voters plan to vote for Rick, 58% plan to vote for Negan. The survey's margin of error is positive and negative 7%. This is how we're going to use it, okay? Does the survey clearly project an outcome of the voting? Okay, so let's get the two intervals first, and then we're going to graph it, and I'm going to show you how we can determine if there is or is not a clear winner. This is how we use it in real day-to-day life, okay? So let's do Rick's margin of error first. So 42%, right, are voting for Rick. So we're going to do 42. We're going to add and we're going to subtract my margin of error, which is 7. Okay, so 42 minus 7 is 35. 42 plus 7 is what, 49? Okay, so that's his interval. I'm actually going to draw that interval on the number line. So here we go. 35 is about here to 49. All right, I'm going to label that Rick. All right, and then with Negan, he is, where is he? 58% are for Negan. So we're going to do 58, and we're also going to add and subtract 7, because that's still my margin of error. 58 minus 7 is 51, and then 58 plus 7 is going to be 65. So that's his interval of possibility. So that is 51 to 65, so there's Negan. Okay, so looking at this, okay, this is how we can predict if an outcome of an election is. In recent years, you might notice some states say it's too close to call. This is part of that process, and then they have to do a revote or a recount. Okay, so looking at this, we can predict. Sorry. We can, there we go. We can predict the outcome because there is not an overlap. Okay, so Rick and Negan, their intervals are separated. Okay, they never ever overlap with each other. So no matter what interval I look at, okay, who is always the winner? Negan, right? Negan is always ahead of Rick. Okay, every single piece of his interval is ahead of Rick's interval. Okay, so that's what we look at. We look at intervals and we look for overlap. If there's an overlap, then there's going to be an area, well, one person is higher than the other and vice versa, right? There is no clear winner. There is a chance where one or the other could win. Okay, but if there's no overlap like this one, clearly we have a winner and it's going to be Negan. There's no interval at all that's going to put Rick ahead of Negan. Okay? Let's do another one. Here we go, example 3, and then you're going to do one after this. Here we go, so we have 3 different ones this time. Survey of random sample voters show 38% of voters plan to vote for Gonzalez, 31% plan to vote for Chang, and 31% plan to vote for Harris. The survey has a margin error of positive and negative 3%. Can we project a clear outcome of my voting? So let's see what happens. So here we go with Gonzalez. Let me change this color back. So with Gonzalez, let's see, we have 38, right, with Gonzalez. So we're going to do 38, add and subtract. Where is it? 3. So 38 minus 3 is 35. 38 plus 3 is 41. Oops, 41. There we go. I'm going to go ahead and put that on here. 35 to 41. All right, so here's Gonzalez. All right, let's go ahead and do Chang. Chang was what, 31? Okay, so 31% for him. Plus and minus 3. 31 minus 3 is going to be 28%. And then 31 plus 3 is going to be 34%. So Chang's interval is between 28 and 34. All right, so that's nice. No overlap there. We still have one more to look at, though. And then we have Harris. So here's Harris, 31% plan to vote for Harris. Well, that's just like Chang, right? So it's actually going to be the exact same interval. Okay, so this one, let's look. Can we predict a winner? Well, I have an overlap, right? I have an overlap between Chang and Harris. But is that going to affect who wins? Does Gonzalez overlap? Like, there is no overlap with Gonzalez at all. So because of that, the overlap that does exist in this problem is not going to affect the outcome. So we can predict the outcome because there is not an overlap with our winning interval. Okay, no one is going to overlap with Gonzalez. So we can predict a winner, and that winner is going to be Gonzalez. Gonzalez. There we go. So there's not an overlap in the intervals with the winner. That's the important part, okay? No one overlap with Gonzalez, so we can clearly conclude from this voting that Gonzalez is going to win. There's no other interval that's going to put anyone else ahead of him. All right, so our next one, here's another 3-person going for, what is this, class president this time. So we have Diana, Drew, and Tate. So I want you to pause, and I want you to do this one, and let's see if we can predict a clear winner or if we cannot. All right, pause the video and try it. All right, check your work with mine. So when we do our intervals, so there's a whole lot of overlapping here. The only overlapping we care about is with the winner. So we do have Tate that is up front, but there is a small little percentage between Drew and Tate, right? So with my margin of error, it could be 35% Tate, 36% Drew, right? And then Drew's the winner. That's the only scenario where it could happen, but it could happen. With this margin of error of positive and negative 4%, it is possible for Drew to win, or it's possible for Tate to win, okay? Is it more likely for Tate? Yes, but we cannot clearly say Tate is going to win no matter what. There is that very small, slight chance that it could be Drew. All right, so for this one, we cannot predict the outcome. There is an overlap with my winning interval, so we cannot predict the winner. There is no winner. All right, we know it's Drew or Tate. So like if I was a part of this school, they would probably do a revote between just those two, right? Diana's out. There was no possible way that Diana could win. Okay, so she would be out. They would probably do a revote between just Drew and Tate for this one. All right, here we go. Next one. So we have some multiple choice problems. All right. So according to a survey of random sample of students voting for student council president, 57% plan to vote for James and 43% plan to vote for Thea. The survey's margin of error is positive and negative 6%. Okay, so let's compare the two and let's see how we can answer. So we have either they overlap or they don't overlap, so we're going to look at that. So we can or cannot predict a clear winner. So I don't have to do any math right here at the very beginning. If they overlap, we cannot predict a winner, right? So we know this is an impossible answer. Okay. Intervals don't overlap. Well, then if they don't overlap, I should be able to pick a clear winner, right? So I know A and D can't possibly, there's no math in the world that would make those true statements. They either overlap, so I can't predict, or they don't overlap, so I can predict. Those are my only two options. Okay, so for any math, A and D are gone. All right, so now let's do our math. Here we go. 50, let's see, James is going to be 57 plus and minus 6, right? So James's interval is between 51% and 63%. And then we have Thea. She is what, 43 plus and minus 6? That's going to give me an interval of 37% to a maximum of 49%. So I can do a number line, but I'm noticing the lowest voting for James is 57. The highest percentage that Thea could get is 49. So just from that right there, I know they can't overlap. It's impossible. Thea's maximum is still lower than James's minimum. Does that make sense? So logically, looking at those margins, I know that they will not overlap, okay? But again, if we need to represent a number line, we can, right? So 37 to 49, right? There's Thea. And then we could do 51 to 63. Boom, there's James. They're not going to overlap. Okay, so because they are not overlapping, we can predict a winner. So our answer here is going to be C. We can clearly state that James is going to be the winner of this student council stuff. All right. Next, let's have you try this one. All right, so pause the video and do this multiple choice question with, who is this? Hickory or Washington? Who do they like to have as the next chairman? All right, so pause and do this one. All right, so this one kind of worked out just like last time. We have our intervals. Again, without the number line, I can tell that Hickory's maximum possible percentage is 45%, and Washington's minimum possible percentage could be 55%. That's a 10% difference. So there's no way possible that Hickory could ever win over Washington, okay, because his maximum is still lower than Washington's minimum, okay? But again, number lines, visuals are great. If I do my number lines, I see there's a clear difference between the two. They are not going to overlap. And also, just like last time, I went ahead and crossed off A and D because those are choices that can never be answers. If they overlap, we cannot. If they do not overlap, we can. So here my answer choice is C. All right, good. Hope you're feeling good about this. Let's pause and do one more. So here, should the fire station be on Northern Avenue? We have 56% say yes, 44% say no. There is a margin of error of 4%. So you let me know, do they have a final answer with their new fire station? So pause and let's see what happens. All right. You probably thought I was going to flip-flop on you, but it's the outcome just like last time. There is no overlap. There is no possible way for the no's to ever outbeat the yeses because the maximum number of no's is 48%. The minimum number of yeses is 52%. So there's no way possible for our no's to take the lead. So again, my answer was C. The intervals do not overlap, so we can predict a clear winner. All right. Beautiful. I have two more. All right, so let's move on to number 4. And again, I want you to pause and I want you to do it. All right, we finally have one where we cannot predict the outcome. So here with the museum, their interval was between 49 and 61%, and the amusement park was between 39 and 51%. So my upper interval is museum, but the lowest percentage is 49, right? My lower interval is amusement park, but the maximum is 51. So there is a small chance where the amusement park could have won, right? If it was 49 and 51, that would have worked. I mean, 50-50, nobody wins, right? So there is an overlap this time. So our answer choice for this has to be B. They overlap, so we cannot predict a clear winner. All right, still doing good? We have one more, last one. Here we go, last one. So this is an error analysis problem, so it's a little bit different, okay? So a reporter for a school newspaper surveys a random sample of students to find out whom they plan to vote for in an upcoming election for student body president, okay? We have our results right here. We have Diedrich, 58%, LeBlanc, 42%. There's a margin of error of 12% for this one. That's really high. So Diedrich begins to celebrate his win because 58 is higher than 42, right? LeBlanc kind of shides him and tells him not to be so sure that he's going to win because the survey is inconclusive, right? So who was correct? Is Diedrich right to celebrate, or is LeBlanc, right to tell him that the survey is inconclusive? All right. So I want you to pause, figure out who's right and why they are right. All right. Go ahead and pause that video. All right, did you pick the right person? LeBlanc is actually correct. Okay, so your answer choices were either between B and D. Okay, he is right to say that the survey is not, that the survey is inconclusive. Okay, because we have intervals that overlap. So because they did have an overlap between the 46 and 51% area, we cannot predict a clear winner. Because anywhere in that interval, one person could beat the other. All right? If Diedrich is 46 and LeBlanc is 51, then LeBlanc wins, right? Or it could be flip-flopped. Diedrich could be 51%, right? And LeBlanc could be 46%. Both of those scenarios are possible in this interval. Okay? So we cannot predict a winner for this particular election. They would have to do it again. Okay? And figure out why their margin of error is so high. So you might notice we're not making you calculate margin of error. We're making you analyze and interpret margin of error and use it to determine if we can or can't conclude an outcome of a voting. All right? So that's all I have today. Easy peasy. Work on the assignment that goes with this and also your quiz review for the quiz that you will have on Friday. All right? Good job, guys.